Students, this is the help video for the ALEKS portion. It's also extra credit, so taking a look here. We are doing these pages together. Highly recommend that you have this page filled out, your two reference book pages, so that you can make reference to it. So we're doing these problems. I'm going to do them live action. I think it's a little bit easier to work with here. All right, it says that QR, so QR is 124, and QS is a tangent. Highly recommend when ALEKS tells you to find something, do not just look for these two. Just focus only on the diagram, which I'm going to do. And you've got two things at play here. First, you have central angles, and measure of a central angle to the arc, it's same. And then you have a tan chord angle. And it's an on, and for that one, angle equals arc over 2. So right here, this is a central angle. So that's QPR, is that one. Measure of a central angle to its arc, the same. And then this one is a tan chord. And it is, anything that's on is half the arc, and this is where you use Post-it notes. So taking a look here, that's an on. And anything that's on the circle, its angles equals half. So it's 124 divided by 2, 62. Okay, next problem. So right here, we are told that arc STQ, so you have to go in that exact order. STQ is 244, and TSR, the angle, TSR, the angle is 124. Okay, what you need to remember is a couple things here. All of these are ons, so you can use Post-it notes. Once again, every on angle is angle equals arc over 2. Also, what you need to watch out for is if you have an inscribed quad, inscribed where all 4 corners are inside the circle, but the vertex is on, opposite angles of an inscribed quad add up to 180. So right here, first thing I'm going to do is I'm going to frame up the angle that grabs this arc, and that's going to be angle R. So if you sweep angle R, you follow it out, you see that angle R grabs that 244 angle. So I get this is 122. And then let's see what other information I have here. I can frame up this orange. Notice I'm completely ignoring the questions. I'm just finding everything possible. This angle is half of, and I follow it around this arc going this way from here to here. And that one's going to be doubled. So it's 248. That would be the arc there. Then we have opposite angles add up to 180. So these angles this way add up to 180. So 124 from 180. And we are going to get here 56. And then coming this way, opposite angles add up to 180, going this way too. And that's 180 minus 122. And we get 58. All right. Now that you have found what you can in the diagram, then you come down here and you just pick out the ones you need. So STQ, STQ, you already found it. It's right there. It's 58. TQR, TQR, you already found it. It is 56. Says in the circle below, QS is a diameter. Stop right there. Diameter. Get in the habit of trace, stretch, sweep, the 180. QT is a tangent. That's a tangent at Q. And you are told that QR is 42. So this arc right there, the purple one, Q to R is 42. And what can you find? So right here, 42 degrees. Always start with what you have. Really simple. If I have 180 here, and this is 42, I get from here to here is 138. And then this side is 180. Let's see what we can do by framing. All of these are ons here. This is all ons. So I could frame right here and sweep the angle, sweep the arc. And you get here, this is an on, so it's angle equals the arc over 2. So if this is 180, back here is going to be 90. Coming this way, I'm going to frame up RQS. And I'm grabbing 138 divided by 2. I get 69. And if I frame up this 42, half of 42, 21. And then to double check, if you add 69 and 21, we get 90, which is what we would expect if you have 90 on one side. So coming over here, we're looking for RQT. RQT. Watch carefully. That's this whole angle. So this one's going to be 69 and 90. 159. RQS. RQS is right here, 69. So keep in mind, tan chords, angle equals half the arc. It's all part of the ons. This is an in, the equation for the in angles, which are chords. Angle equals arc plus arc over 2. So right here, what are we given? We're given PUR, this angle right here is 41. ST, this arc is 42. and we're trying to find RP. Let me color code this for you. These angles, either one of them, angle, would equal this arc plus this arc over 2. So circle, plug, chug. This is going to be 41 equals 1 arc, 42 plus unknown arc, we'll call it x over 2. Cross multiply. And we're saying that's 40. What's really nice, it's super easy to check this. You just do 42 plus 40. That equals 82 divided by 2. You get 41 and check, there is your angle. So the N is arc plus arc over 2. This is an out. So secant, secant, tan, secant, and tan, tans are all out. This one is angle equals big arc minus little arc over 2. Big arc in this diagram would be this way. Little arc this way over 2. Let's see what we've been given. We've been given ADB, which is this one, is 241. That would be my angle. So we're missing this arc here, but it's a tan tan. So if you go like this with your finger, you can see that they add up to 360. So I can do 241 from 360. And I should get 119. And here, so angle equals big arc 241 minus little arc 119 over 2. Get 122. Divided by 2, and we get 61 degrees. Says in the figure below, IL and IJ are tangent to the circle at Q. So be really careful. Yes, IL is tangent, but the trick to this is realizing I to J, which is the point of tangency, and I to K, which is the point of tangency, are going to be congruent. Segment LJ, make that blue. LJ passes through the center of circle. All right, so we have LJ, which is the blue, is 9.9. And we are told that IL, which is this whole thing, IL is 16.5. We're trying to find LK, which is just this orange question mark. Now you can see here, go like this with your fingers. If we get the purple, which we have, and we find the yellow, which we don't have, to get this orange, it's simply purple minus the yellow will get us that orange piece. So here's the trick. Tan tan, arms of a tan tan. Point of tangency are congruent. So I'm going to solve for x. Tangent to a radius, radius of tangent to a radius, right angle at the edge. Got a right angle there. So let me color code that for you. This is the blue. This is the purple. And our unknown is going to be the yellow. So if I were to solve for this, it'd be x squared, 16.5 squared, minus 9.9 squared, square root both sides. So x equals the square root of 16.5 squared minus 9.9 squared. So we're going to go 16.5 squared (9.9 squared) I end up with the square root of 172.24, square root, x equals 13.2. Now, knowing that this is 13.2, this over here, if you swing it around, is also 13.2. So to get my orange, I simply do 16.5 minus 13.2. And your final answer there is 3.3. Says the equation of the circles given below, identify the center, radius, and graph. So here, we want to find the h, the k, and the radius. H, K, radius. So notice the sign does not swap. That means your h had to have been 4. Here the sign did swap. So that means your k had to be -5. And last one, I'm going to have r squared equals 9. Therefore, our radius is 3. So to graph this, we are going to have 4, -5, up 3, to the right 3, down 3, left 3. And there's your graph. Says a street is 160 meters long, covered in snow. City workers are using a snowplow to clear the street. A tire on the snowplow turns 40 times, traveling the length of the street. What is the diameter of the tire? First off, just organize all your pieces. We are told we are going to travel 160 meters long. We are told the tire here turns 40 times to go 160 meters. 40 turns equals 160 meters. We're asking, what is the diameter? The first thing you need to establish here is the fact that a turn, when a wheel turns, it's traveling the length of the circumference. That's the trick to the whole problem. When it says it turns or revolves, that is the length of the circumference. So turn and circumference are the same thing. So I have for 40 circumferences equals 160. Circumference equals, and we have here 4 meters. Be very careful. 4 meters is not your answer. You're not being asked for the circumference of the circle, which that is. You're being asked for the diameter. That's what you're being asked for. C, d pi, I see d pi. C, d pi, I see d pi. So your circumference is d pi, and we're solving for our diameter here. That's what we actually want. So we're going to divide both sides by pi. Now, super important, you do not use the pi key when you're working with ALEKS. You do not use your pi key. It wants you specifically and only to use 3.14. So this is 4 divided by only 3.14. Do not use the pi key on your calculator for ALEKS. 4 divided by 3.14. And it says do not round any intermediate answer, but it wants you to round your final answer to the nearest 10, which here, diameter is going to be approximately 1.3 meters. We're going to write an equation of a circle with a center at -6, 0, and a diameter of 10. So HK is our center. So we at least graph that. -6, +7. -6, I'll go 1 over, excuse me. Okay, -6, +7. That's your HK. Our diameter is 10 units. So that means our radius is 5. So your circle is going to look something like this. So it wants the equation, so it's x minus h squared, y minus k squared equals radius squared. Our h is going to go right here, k there, radius there. Then you do your cleanup. X minus -6 squared, y minus 7 squared equals 5 squared. A little bit of cleanup, double negative makes a positive. Your final answer here for this is x plus 6 parentheses squared, y minus 7 parentheses squared equals 25. Find the equation of a circle. When we say equation of a circle, we mean this. That has a center of -6 and +2. Once again, that's already your HK, but passes through this point. So what that looks like visually is this. -6, +2 is the center of my circle. Then I have this passes through, +2, -5. That means that my circle goes through this point. My circle is going to look something like this. So that's my circle. Don't worry for the fact that it goes off a graph. There's only 2 things you need for an equation of a radius: a center, HK, and a radius. So we already have our center. What we're missing is our radius length. And the radius of this circle is going to be the distance between those 2 points. So we're going to do the distance equation. Want the distance here. So I connect x to x, y to y. So I get my distance here is a square root of 113. So my radius equals the square root of 113. What does that look like in the equation? So I come over here and I have x minus h squared, y minus k squared equals radius squared. That's going to be x minus negative 6 squared, y minus 2 squared equals root 113 squared. Final version is x plus 6 squared, y minus 2 squared. Root 113 squared is simply 113. That is the equation of this circle with that center and a point on the circle. We want to find an equation of a circle whose diameter has endpoints. Endpoints. So right here we have -1, -4. And 1 and 6. So this is our diameter. So our circle is going to look something like this. Sketching. There's only two things you need for a center, for an equation of a circle. You need a center, which is HK, and you need a radius, neither of which you have here. But what you want to notice here is in this diameter, if you found the middle of the diameter, you find the center of the circle. So we're first going to find the midpoint between these 2 points. Add the x's, divide by 2, add the y's, divide by 2. If you've done this correctly, you have found the midpoint of your diameter, which is also going to be your HK. And if you've graphed it properly, it actually looks like the center of the circle. So I have 0, 1 as the center of my circle, which is now my HK. Now this is similar to the previous problem where to find the radius, we're going to use the distance equation. You can go either this way or this way. I'm going to go up here because it's all positive, just to make it a little bit, at least in my mind, I don't have to worry about double negatives. All right, so I'm going to go x minus x, y minus y. And the square root of 26 equals my radius. So I come over here, and your equation is going to be here's your equation. Your h and your k are over here, 1 and 0. So there's a 0 here, and a 1 here, and a root 26 here. That's what we plugged in for the h, the k, and the radius. Break down the equation around it. And x minus nothing is just x. Root 26 squared is just 26. There would be your final answer.